Hey learners, welcome to episode 12 of our Neet Chemistry series for 2025 and 2026. I am Chongtham David, your mentor, and today we are entering the diverse and colorful territory of the P block elements, where trains ban, exceptions rule, and the real chemistry magic unfolds. From group 13 to 18, we'll explore 45 handpicked questions covering structure, reactivity, and real life applications that NEET loves to test. Here's something to think about: versatility is strength, and just like the P block elements show a wide range of behavior, your ability to adapt and understand these twists will give you a sharp edge in the exam. Let's decode the patterns, embrace the exceptions, and master this essential chapter together. Now we're left with only a few days, approximately 20 days, so make the best use of it. Without any further ado, I'm going to share the screen. The first question: the brown ring test for nitride and nitrate is due to the formation of complex with a formula. This brown ring is a complex coordination compound. It is actually pentaaqua nitrosyl ferrous sulfate. So after this dissociation of the complex in the medium, aqueous medium, you are going to obtain the ion. So first of all, let us write down the structure of the complex. This is called pentaaqua. The ligands are different, heteroleptic, and the nomenclature part I have already explained how to name this complex. It starts from the alphabetical order A, and this is N, right? So there are five aqua and nitrosyl followed by the name of the central ligand. So we call this penta-aqua nitrosyl ferrous, then put the oxidation state plus 2 sulfate. Anyway, in the aqueous medium, this can dissociate into ions. The ligands present outside the coordination pair, also known as the ionization pair, would change to ions. So the name of this complex would be penta-aqua-nitrosyl iron 2 ion. So the brown test for nitride and nitrate is due to the formation of complex ion with the formula. Option C would be the correct answer. I hope it is understood. Let us read question number 2. Moving on to question number 2. Which of the following shows nitrogen with its increasing order of oxidation number? Now, to answer this question, I'm going to show you a table here. Let us put up a table compound in the first column and the oxidation state of the central atom in all the case, which is your nitrogen, right? So first you have nitrous oxide, N2O. The oxidation state is +1. What about nitric oxide? The oxidation state is +2. What about nitrogen dioxide? Keep on finding. +4. I hope you can find the oxidation state of the central atom. Now you're at the edge of the exam. You must be well prepared. +5. And the remaining ion, one I have ammonium. I'll write it here. The oxidation state corresponds to no, it should be -3. So looking at this oxidation state, the order of oxidation state of nitrogen follows ammonium, then nitrous oxide, right? Then individually you can keep on comparing nitric oxide, nitrogen dioxide, and NO3 minus. This nitrogen is a nicogen. It is in the group 15, the first family, and the second period elements, which is the first family in the respective group, will show anomalous strain due to the small size, absence of vacant d orbital, and high ionization enthalpy. Anyway, let us come to the question. Question number 2, if you look at this strain, the answer would be option C. It is okay. Question number 2, option C is the correct answer. Let us move on to the next question number 3. Which one of the following is the correct decreasing order of boiling point? So you are given hydrides of group 16. You know the common name of group 16 is called chalcogens, right? So question number 3, I'm going to give you some more options in the next slide. Water, hydrogen sulfide, selenium hydride, tellurium hydride, or tellurium hydride. You're given different kinds of hydrides in the decreasing pattern. So how to answer this question? Among the hydrides of this group 16 elements, the boiling point of water is the highest, is the high, it is more than hydrogen sulfide. You know, the difference in this boiling points of water and hydrogen sulfide is roughly about 200 degrees Celsius. You know, it is due to the strong intermolecular hydrogen bonding present in water molecule. Now, as you go down the group, the decrease in boiling point from water to hydrogen sulfide, further from hydrogen sulfide to hydrogen, this tellurium hydride, it is mainly due to increase in the size of the atoms from sulfur to tellurium. Then what happens? As the size increase, the magnitude of the van der Waals force among the molecules will also increase. So the correct order of the boiling point now can be represented as water due to hydrogen bonding, tellurium hydride due to the atomic size of the central atom in the group 16 elements. You have selenium, then you have hydrogen sulfide. Okay, I have wrongly written here. Let me erase this one. Good. Now it looks tidy. So compare this with the given options. D would be the answer to question number 3. I hope it is understood. Let us move on to the next question. The true statement for the acids are phosphorus, phosphoric, and okay, this acid is in which order? The order of the acidity is given here. All of them are reducing in nature. All of them are tribasics. The geometry of the phosphorus is tetrahedral in all the cases. Now, the geometry of the phosphorus is tetrahedral in all the cases. It is correct. You know why? If you write the Lewis structure, the central atom phosphorus you have, and one replaceable OH, H. So this is the structure of H3PO2. Let us keep on writing for the remaining oxy acids of phosphorus. You know, when I say oxy acids, it means oxygen containing acids. So you have two replaceable hydroxide ions, which means its acidity would be 2, dibasic. What about the next oxyacid of phosphorus? Since phosphorus is pentavalent, you have 3 replaceable hydroxy group. So it must be a tribasic. You have phosphoric acid, phosphorus acid, right? So in all the cases, it has tetrahedral structure. That is correct. Then the acidity increase with the increase in the oxidation number of the central atom. So what is the oxidation state of the central atom? It would be plus 1. What about this acid? It would be in plus 3. What about this acid? It would be in plus 5. You know how to find the oxidation state, right? So compare this, then the acidic character will keep on increasing from H3PO2 because it has less oxidation state in the central atom, PO3, then H3PO4 phosphoric acid. It has plus 5, here it has plus 3, here it has only plus 1. And this phosphoric acid, it is not reducing in nature. It is going to be oxidizing in nature. However, this H3PO3 is dibasic, while this H3PO2 will be monobasic. So the order of their acidity is okay. This is the correct statement. All of them are reducing is not the correct answer because phosphoric acid is oxidizing. All of them are tribasic is not correct because one is monobasic, tribasic, and dibasic. And the geometry of the phosphorus is tetrahedral in all the 3 cases. So the answer would be A and D, right? But let us check back again. Okay, I have made a mistake here. The sequence would be in this way. So 1 is not the answer. D is the answer for this question. If the inequality symbol is reversed, it would be correct, right? So 1 is not the answer for question number 4. 4 answer would be option D. Let us read question number 5. The acid which forms two series of salts is. So these acids, if I give you the structure, it would be something that looks like this. So it can form two series of salts by the replacement of this hydrogen attached to oxygen. So the acid which forms two series of salt would be phosphorus acid. So 5, option B is the correct answer. Question number 6. The nitrogen oxides that contains nitrogen-nitrogen bonds are or is. So for question number 6, let us write the structure of this nitrogen-nitrogen triple bond oxygen. This you have as nitrous oxide. This is the Lewis structure. And for dinitrogen trioxide, I would have the structure as such, which is the Lewis structure of dinitrogen trioxide. And the dimerization of nitrogen dioxide would result in the formation of dinitrogen tetraoxide, which would look like this. This is structure number 3. And structure number 4, that is dinitrogen pentoxide, would look something like this. Oxygen is the bridge atom, double bond. This is your dinitrogen pentoxide. So the nitrogen oxides that contain nitrogen-nitrogen bond, you have to check this. Option 1 contains, 2 has this nitrogen-nitrogen bond. Okay. What about option number 3? Yes, it has nitrogen-nitrogen bond, but this nitrogen-nitrogen bond is absent in option number 4. That is dinitrogen pentoxide due to this bridging oxygen atom. So if 1, 2, and 3 are correct, D is the answer to this question number 6. I hope it is understood. Let us read question number 7. The geometry of chloride according to valence shell electronic pair repulsion theory will be. So this hybridization is going to govern the shapes or geometry of this ion. So if I write the structure of the ClO3, it would be, yes, 3 oxygen, and there are coordinate bonds. Let us write the lone pair present here. 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Check out the theory part, how to draw the Lewis structure. So after this, resonating structure is possible. Oxygen, knowing the Lewis structure is very crucial for chemical bonding. 1, 2, 3, 4. Then oxygen, oxygen, double oxygen, chlorine, double bond, 1, 2, 3, 4. So this is the structure. Now this central atom is going to be in which hybridization? I will give you the formula to find hybridization. Half valence atom, monovalent, cation charge plus anionic charge. So as you can see from this given structure, the central atom is chlorine. There are 7 electrons. There is no monovalent atom, that is atom which has 1 valency. Cation charge is absent and there is 1 anion. So if you calculate, you get 4. This corresponds to sp3 hybridization. I hope it is clear. And this sp3 hybridization, there would be 2 types of geometry. One is regular and another one is irregular. If there is lone pair of electrons, the geometry is not regular. Regular geometry would be tetrahedral. But here in this case, there is one lone pair of electrons, so the shape would be pyramidal. Okay, it pushes this bonding electrons by the lone pair. Repulsion will be present according to valence shell electronic pair repulsion theory. You have learned lone pair repulsion is greater than lone pair bond pair, then bond pair repulsion. So what happens? This atom would try to be in the most stable state. Okay, it doesn't want to conflict with these atoms which are not stable. Chloride. Then you have this pyramidal geometry. I hope this is understood. So B is the answer to question number 7. Moving into the next question, question number 8. It is possible to obtain oxygen from air by fractional distillation because the air is liquefied by using or by use of the Joule-Thomson's coefficient. Remember, it is cooling by expansion of the gas. When you cool the gas, there will be expansion of the gas. So what happens? The water vapor and carbon dioxide are going to be removed by the process called solidification. And the remaining constituents of liquid air, that is liquid oxygen and liquid nitrogen, are going to be separated by the means of fractional distillation. And usually this fractional distillation is employed where there is a minimum difference in the boiling point. So remember, there is difference in the boiling point of a little. There, the boiling point is not that much for oxygen and nitrogen. Okay, for oxygen, the boiling point is approximately minus 183 point. Okay, 183 degrees Celsius. Let's say nitrogen is about 195.8. So the difference in the boiling point is not that much. And due to this, you can separate by fractional distillation. And now, if we look at the question, it says it is possible to obtain oxygen from air by fractional distillation because it is due to oxygen has higher boiling point than this nitrogen. So option C would be the correct answer for question number 8. I hope it is clear. Let's see question number 9. Which of the following is the most basic oxide? See, remember the rule of the thumb. When metal oxide forms, the compound would be basic usually. Okay, this is the rule of the thumb, and non-metal oxides are usually acidic in character. So more the oxidation state, there is another key concept, or higher the oxidation state, higher will be the acidity. Okay, so more the oxidation state of the central atom, the metal is going to be very acidic. In this selenium oxide, selenium has +4 oxidation state. It is very acidic, and for a given oxidation state, the basic character of the oxides increase with the size. I have already explained here. Okay, size is very much related with the acidity and basicity. And remember, the basic character of oxides increase with the increasing size of the central atom, that is, becoming more and more metallic. Thus, this aluminum oxide and tin oxide are going to be amphoteric, and this bismuth oxide, which is the largest in size, would be basic in nature. So question number 9, bismuth oxide is the most basic in character. I hope this is understood. Let us read question number 10. Which of the following compound is used in photography? Very simple. Thiosulfate salt of sodium. Remember this name. Then question number 11, the oxy acids. I have already explained to you before what are oxy acids, right? Acids containing oxygen atom. So this oxy acids of phosphorus, in which phosphorus has the lowest oxidation state, is, we've done this before, it would be hypophosphorus acid. You know the formula of hypophosphorus acid? H3PO2. Hypo. I will give you the names of some oxy acids of phosphorus. This is called phosphorus, and this would be called phosphoric acid. but this one is called hypophosphorus. It has the lowest oxidation state of plus 2. So option A for question number 11 would be the correct answer. Moving on to question number 12. Which of the following statement is not valid for oxo acids of phosphorus? Okay, the given options are not complete. I'm going to show you, but first let us read these options. A. Orthophosphoric acid is used in the manufacture of triple superphosphate. Hypophosphorus acid is a diprotic acid. You are required to find the statement which is not valid. Okay. All the oxo acids contain tetrahedral 4-coordinated phosphorus atom. All the oxo acids contain at least one phosphorus double bond oxygen and phosphorus hydroxy group. So for question number 12, to answer this question, see hypophosphorus acid. This acid would have the structure like this. HP double bond O. I have already explained before in the first earlier part of the question that it is a monobasic because it has one replaceable hydroxy group. And the name of this oxoacid is called hypophosphorus acid. Hypophosphorus acid. Okay, so this is a monobasic because it has one replaceable OH group and it has only one ionizable atom or one OH group is present. So B, it is a diprotic acid. We'll call this D. This is not a monoprotic. It is a diprotic acid. This is the wrong answer. Sorry, wrong statement. Wrong statement would be the correct answer because the question is saying not the valid statement. Question number 13. Which one of the following reactions of Zenon compounds? I will give you one more key important points here. Maybe those students might know what is the name of the scientists who discovered this noble gases. Most of them were discovered by Ramsay and Rayleigh. Okay, scientists' names are also important. Anyway, let's read the question 13. Now, these reactions of xenon which are not feasible. Let us check. The first reaction, this is very much possible. Xenon trioxide is an explosive compound. Xenon difluoride on hydrolysis yields xenon NHCl. This is also correct. Xenon hexafluoride and rubidium fluoride gives rubidium xenon compounds. You know, in the recent newspapers, uranium salts, these are asked in the UPSC exam. So sometimes this kind of questions are also going to be very important, even in your NEET exam. So read this thoroughly. The last option, xenon trioxide and hydrogen fluoride. When these two reacts, it gives xenon hexafluoride and water molecule. Is this the correct answer? No, this is not the correct product. The correct product would be xenon trioxide and hydrogen fluoride. Right? So 13, it comes back, okay, to the initial reactions. See, the products of the constant reactions react each other, forming back the reactants. It is not feasible. It can come back to the initial reacting stage. So this is not the feasible reaction. So D would be the answer for this question. It is not feasible. Let us read question number 14. The compounds of sulfur that can be used as a refrigerant is. So due to this large enthalpy of vaporization of sulfur dioxide, it can be used as refrigerant. Then you have to answer. A is the answer. Due to the large enthalpy of vaporization. Let us read question number 15. Which of the following on thermal decomposition gives oxygen gas? On thermal decomposition means by heating, it has to dissociate. So let us write the reaction for the first case. An oxide of silver, it can decompose to silver and oxygen. Whereas for this lead oxide, if I decompose this, you get, this was a dimeric form of lead oxide, same condition, but the oxidation states are different. Then lead oxide PbO2 gives PbO plus oxygen. So which of the following on thermal decomposition gives oxygen gas? For this particular silver oxide, oxygen is liberated, and also for this lead oxide, it also liberates this oxygen gas. And for lead oxide, PbO2, same thing, oxygen gas is liberated. So all of this will liberate oxygen gas on thermal decomposition. These metal oxides liberate oxygen gas on thermal decomposition. So D would be the answer for question number 15. I hope it is understood. Let us move on to question number 16. Which of the following statements are correct? Arsenic, antimony are metalloids. Phosphorus, arsenic, antimony are found mainly as sulfide ores. Covalent radii increase equally from nitrogen to bismuth. Elements of group 15 have extra stability and higher ionization energy due to a half-filled NS2 NP3 configuration, electronic configuration. In group 15 elements, only nitrogen gas is gas, whereas all others are solid. So for question number 16, what you have to do is you have to find the correct statements. Remember, this phosphorus occurs in minerals. We call it the apatite family, such as calcium phosphate. It can exist as Ca9PO4 6 or calcium dihalide. This H can be, sorry, dihalide, or you can say dihydroxy stage. X can be chlorine, or even hydroxy group. Calcium hydroxide, that is lime water, calcium fluoride or calcium chloride or calcium phosphate. We call it the apatite family, right? So these are the main components of rocks where phosphates are found, whereas arsenic and antimony are found as sulfide minerals. And the increase in covalent radii from nitrogen to phosphorus is greater in comparison to increase from arsenic to bismuth. So for this question, 1 is correct and this 2 is wrong. 3 is correct, 4 is correct, 3 is also wrong, 4 and 5 would also be the correct answer. So 1, 4 and 5. So option A is the correct answer for question number 16. Moving on to question number 17, the formation of this salt is the basis for the formation of xenon fluorides. This is because of, you see, the first ionization enthalpy of xenon is 1170 kilojoule per mole, very large, 1170 kilojoule per mole. And this is very close to that of dioxygen. Okay, for xenon, we have given here. And for oxygen, we have 1180 kilojoule per. So this is a very close value. And the molecular diameters of xenon and dioxygen gas are almost identical. So based on the above similarities, there's a scientist whose name is called Mr. Bartlett. I'll write it for you here. His name is called Mr. Bartlett, right? Bartlett, he is going to prepare this salt. And he suggested that oxygen, since this oxygen combines with platinum hexafluoride, xenon should also form similar compounds with platinum hexafluoride. I think this is mentioned in your NCERT. Read thoroughly the textual part and you will find this. So reading NCERT is very important for your NEET exam. Anyway, let us read this question and answer. The formation of this salt, this is a complex salt, is the basis for the formation of xenon fluorides. So this is because oxygen and xenon have comparable size. I have already explained before. And this both, these are gas, this is not the answer. Oxygen and xenon have comparable ionization energy, this one, which I have just explained. For xenon, you have 1170, whereas for oxygen, you have 1180. So this is the correct answer for question number 17. I hope it is understood. If you have any problem or query, you can give in the comment section. Let us give answer to the next question, question number 18. Oxidation of thiosulfate by iodine gives which of the following ions? So thiosulfate, we have just explained, it can also exist with sodium. Okay. This thiosulfate ions, let us write down by the reaction with iodine. So S2O3. So initially we have two sodium atom, and after ionization you have two minus. This is the correct formula of thiosulfate ion reacts with iodine. This would change to a tetrathiode ion, which has the formula S4AO6, same oxidation state of this anion, 2 minus, and to have to balance this iodide. There's decrease in the oxidation number for iodine, so it is undergoing reduction. This is the oxidizing agent. Okay, so for question number 18, A is the answer for question 18. Clear? Moving on to question number 19, easy question. This is an interhalogen compound. Iodine heptachloride, the hybridization for this would be, so use the formula I've given before. Half valence, monovalent charge should be minus, okay, minus, and then charge on the anion. So using this formula, you can decode the hybridization value for ICl7. So what is the valence electron used here for iodine 7? And there are 7 monovalent atoms, 7 chlorine, and addition and subtraction, you get 7 itself. So this must be in sp3d3 configuration. sp3d3 is option 19. Okay. Question number 20. 20, let's read. We have to match the column. Lead oxide would be best paired with, this is your mixed oxide, okay? A combination of PbO, Pb2, okay. So A is a mixed oxide. And this B would be best paired with, this is a neutral oxide. Then this manganese oxide would be, it is acidic. Bismuth would be basic. So A4B1C2D3. B is the answer for question number 20. I hope it is understood. Let's read question number 21 also. Which one of the following arrangement does not give the correct picture of the trains indicated against it? So we have oxidizing power, electron gain enthalpy, bond dissociation energy, electronegativity. So based on this, you have to answer the question. So from the given options, we find that this option number 1, that is fluorine, chlorine, bromine, iodine, oxidizing power, this is correct, right? And this option number 2, regarding the electron gain enthalpy, it is not correct, incorrect, because the correct order of electron gain enthalpy for halogens would be chlorine will be more. Okay, this is an exception because chlorine, due to the extremely small size, you cannot add easily to the 2p electronic system. So the actual decreasing order would be this one. But you have fluorine in the first place. So this is not the correct answer. And for option number 3, this is also incorrect. Why the bond dissociation energy is not decreasing in this way? Because the correct bond order, decreasing order of halogens is also related with this electron gain enthalpy. Fluorine should come next to chlorine. Okay, so option 3 is also incorrect. And what about electronegativity? This is correct. So if option 1 and if option 4 alone are correct, right? The correct order of electronegativity values. So option 2 and 3 are incorrect. 2 and 3 are incorrect. So question is asking which one of the following does not give the correct. Okay, 2 and 3. You have to say 2 and 3 is the answer. 2 and 3, option C. Okay, good. Let's move on to question number 22. Which of the following is a saline oxide? Oxides, which are more ionic in nature, just like the characteristics of salt, they are known as saline oxides. That is, oxides of group 1 alkali metals. So 22 would be sodium oxide, would be saline oxide. Question number 23. Shape of xenon oxide tetrafluoride. What is this? So you explain this based on the hybridization. Same thing, we have to write the the formula. H equals to half valence plus monovalent minus charge on the cation plus charge on the anion. So the shape would take up square pyramidal. Okay. 23 is B. 24. Which among the following is paramagnetic? Paramagnetic means those which has unpaired electrons. You see this ClO2, it contains 7 electrons. 7 electrons on the central atom plus 12, 6 into 2 is 12. So what is the result in total? 19 electrons are present on the valence shell. So this is an odd number, right? So that means there is free electrons. Odd represents free, so this must be the answer. If there's no free electrons, there would be a diamagnetic character. Pairing of electron would have taken place. Question number 25. The molecule having the smallest bond angle is. Okay, let's read all this. Nitrogen trichloride, arsenic trichloride, stibbium trichloride, phosphorus trichloride. Okay. All the members form volatile halides, okay, of this formula AX3. And all halides are pyramidal in shape, and the bond angle decrease as you go down the group due to the increase in the bond pair repulsion. So NCl3, for your side knowledge, you can remember the bond angles which I'm going to give you here: arsenic and stibbium antimony trichloride. They are all obeying this general formula AX3, and the central atom has a bond angle 107, 109.5 degree and 98, 97.2 for this. So arsenic, this stibbium tin chloride, it has the least bond angle. So option C would be the answer to question number 25. I hope it is clear. Question number 26. Which one of the following orders correctly represents the increasing acid strength of the given acids? So if you write down all the oxidation state, HOCl, it is in +1 oxidation state. HOClO, it is in +3 oxidation state. What about HOClO2? Okay, let me give you an example how to find Cl, right? So +1, then you can give here -2, X 2 into -2. So overall the oxidation state would be +5. Okay, in this way you can proceed. HOClO3, the oxidation state of the central atom would be +7. So do you see that there is increasing in the oxidation state as you go along this left to right, right? So 26, in case of this oxyacids of similar element, the oxidation number of the central atom keeps on increasing, right? So the strength of the acid also increases. So this must be the correct answer. Increasing acid strength means increasing in the oxidation state. Or non-metallic, they are going to be also acidic, right? But if you are given the same type of uh, elements, you have to check the oxidation state. Higher the oxidation state, more is the acidic character. Good. See question number 27. The ease of liquefaction of noble gases increase in which order? So the question is giving you multiple types of options. You have to choose the correct answer. See, remember the rule of the thumb. As the size increases, van der Waals force of attraction between the noble gases atoms also increases. Consequently, what happens? The ease of their liquefaction will also increase. So, which means helium, neon, argon, krypton, xenon, this would follow due to the van der Waals size. So, A is the answer to question number 27. I hope it is clear. Let us read question number 28. A certain compound X, when treated with copper sulfate solution, yields a brown precipitate. Mark this point. On the addition of hypo solution, the precipitate turns white. The compound is. So when this potassium iodide starch solution is added to copper sulfate, Ki is your starch solution, you're going to obtain potassium salt, potassium sulfate, and cuprous iodide. Some students have a confusion on cupric and cuprous. Okay, the one with the highest oxidation state will always be ending with IC. And this is brown, okay, brown color in solution. And this one is cuprous iodide. This is your white precipitate. Okay. Now, if I add a hyposolution is your sodium thiosulfate. We call it in common terms hyposolution. If this is treated again with this iodine, it now generates sodium tetrathionate. We have done this also before. Tetrathionate has S4O6 2 minus, and one salt will be also released. To balance this, I write here 2 and write it here 2. Right, so sodium tetrathionate, this is a colorless. This is not colorful, it is colorless, right? So read this question 28. On the what is the compound? After see read the question first. A certain compound X, when treated with copper sulfate solution, yields a brown precipitate. This brown precipitate on addition with a hypo solution, that is sodium thiosulfate, it gives a colorless sodium tetrathionate. So what is this compound X? Right? So compound X is your potassium iodide. So 28, option B is the correct answer. I hope this is logically clear. Moving on to the next question, question number 29. Which of the following species is not a pseudohalite? So this acetate ion, this would not be a pseudohalite. Okay. Question number 30. Which of the following is used to produce a sustained, powerful superconducting magnets to form an essential part of this NMR spectrometer? So this is option D. Okay. Let's read question number D. Helium is added. Okay. Question number 31. The product obtained as a result of a reaction of nitrogen with calcium carbide is addition of calcium carbide. It would be calcium cyanide. How to write this reaction? Carbide reacts with this nitrogen gives calcium cyanide and carbon. So A would be the answer for question 31. 32. Which of the following noble gases has the highest negative electron gain enthalpy? Remember, electron gain enthalpy for noble gas is positive, and it becomes less positive with the increase in the size of the atom down the group. The value of electron gain enthalpy would be such that helium, the value I can provide you here, 48 kilojoule per mole. Okay. Neon would be approximately 1116 kilojoule per mole. Argon, krypton, nearly 96 kilojoule per mole. Then you have xenon, which is approximately 77 kilojoule per mole. So for question number 32, you are asked to find which of the following noble gas has the highest negative electron gain enthalpy. So from this value, it is evident that neon, okay, this electron gain enthalpy would be the highest for neon. Okay, let us move on to the next question. Neon has 160, right? Question number 33. I hope you're all keeping up with me. Gaseous HCl is a poor conductor of electricity while its aqueous solution is a good conductor. This is because option A, water is good conductor of electricity. A gas cannot conduct electricity, but a liquid can conduct. HCl gas does not obey Ohm's law, whereas the solution does. HCl ionizes in aqueous solution. So in gaseous state, the HCl is covalent in nature, while in aqueous solution, it ionizes to give hydrogen and chloride ion. So HCl ionizes in aqueous solution. This is the answer. This is the answer to question number 33. Question number 34. Density of nitrogen gas prepared from air is slightly greater than that of nitrogen prepared by chemical reaction from a compound of nitrogen to the presence of argon, carbon dioxide, some nitrogen N3 molecules analogous to ozone, greater amount of nitrogen molecules derived from N15 isotopes. So air, we know it contains about only few percentage of very few percentage of inert gas, mainly that also argon. You know the atomic mass of argon is 40, whereas the major component nitrogen is only 28. Right. So A would be the answer to question number 34. Moving on to the next question. We are about to be done soon. Keep up with me. The correct order of acidic strength is. I have already explained this multiple times. This is an important question because the acidity and the basic characters are always asked multiple times in your NEET exam for P block elements. Non-metallic oxides are acidic and acidic character decrease with decreasing non-metallic character. So compare this, you are going to obtain option A is the correct answer, right? Okay. Question number 36. Sulfur trioxide can be obtained by which of the following reactions? 36. So it can be obtained by heating or thermal decomposition of ferric sulfate. It dissociates and gives ferric oxide and sulfur trioxide gas, right? So 36 would be B. Moving on to the next important question, 37. The correct order of increasing bond angles in the following species are. So the correct order of increasing bond angle is, okay, let us write the structure for Cl2O. You should always remember, okay, writing the Lewis structure is very important. If you don't know how to write this, it will become a big problem for most of the chapters from class 11 standards, be it covalent chemical bonding or P block elements or periodic classification or even thermodynamics. Okay, so these are some of the Lewis structure which I'm going to draw here, and even hybridization also. So this is foundation concept. You have to remember thoroughly. Chlorine, lone pair electron is 2. So you have to write here oxygen, a coordinate bond. Okay, multiple bond is treated as single bond for geometry. So this must be a bond angle of 110. So if you arrange this, you will find the correct order of increasing bond angle would be Cl2O followed by ClO2 minus, then ClO2. See, in case of ClO2 minus, there are two lone pair of electrons, and these are present on the central chlorine atom. So therefore, what happens? The bond angle in ClO2 minus is less than 118 degree, which is the bond angle in ClO2. So this has less number of electrons on the central chlorine atom. I have given you this sequence. The answer would be C. I hope it is clear. Let us read question number 38. Which one of the following oxides of chlorine is obtained by passing dry chlorine over silver chloride at 90 degree Celsius? See, pure this chloride, ClO2, chlorine oxide, is obtained by passing dry chlorine over silver chloride at 90 degrees Celsius. So you can write this reaction, silver chloride, AgClO3, when you pass chlorine gas in dry condition at a temperature of 90 degrees Celsius, it gives silver chloride and chlorine oxide along with oxygen gas, right? So ClO2 is liberated here. 38, option C would be the answer. 39, the shape of this xenon dioxide difluoride molecule is. Same thing again. You have to remember the Lewis structure. Based on that, find out the hybridization on the central atom. That would give you the shape or geometry of the molecule. So this xenon dioxide difluoride has trigonal bipyramidal geometry. I'm going to show you how. Okay, one lone pair. So due to the presence of this lone pair, electrons on the equatorial position, its actual shape is going to be seesaw. So it would be seesaw. Because lone pair, it has irregular geometry. Whenever there is no lone pair, it will be a perfect geometry, regular geometry. Moving on to the next question, question number 40. Number of lone pairs of electrons on xenon atoms, xenon difluoride, xenon tetrafluoride, xenon hexafluoride molecules are respectively. So there's xenon difluoride, you're having, okay, let us write it down, xenon tetrafluoride and hexafluoride. So what is the valence electron? Let me write it here, put it in this way. Let's say valence electron. 8, because central atom is octet. Electrons involved in this bond formation would be, let me write here, electrons involved in bonding, let's say. Bonding electrons, if you count, it would be 2. From the xenon, you have 4 from this xenon and 6. So how many lone pair of electrons are left? 3 here, 2 here, then 1 in this case. So 3, 2, 1. Question is asking number of lone pair of electrons on xenon in this compound. 3 to 1. A is the answer for question number 40. I hope it is understood. Good. Let's read question number 41. This is a match the following type, and this is also expected question. So x prime, xx ds prime, xx ds, sorry, 3 prime, xs 5 prime, xx 7 prime. The geometry you have to match correctly, right? So this x prime would be linear, okay? And this x3b ds would be T shape. X5 ds would be square pyramidal. X7 prime would be D2. So option A. You see, sometimes questions are going to be very similar with bonding. Question number 42. The crystals of ferrous sulfate on heating gives. Ferrous sulfate, it has 7 water molecules. Water of crystallization is 7 water molecules. So when you heat this, you will have, this is actually a green salt, plus 7 molecules of water, right? So further heat this again, you will now have oxide of iron, sulfur dioxide. And sometimes a few traces of sulfur trioxide may also be present. So C would be the answer for question number 42. I hope it is understood. Let's read question number 43. 1 mole of fluorine is reacted with 2 moles of hot and concentrated potassium hydroxide. The products form are potassium fluoride, water, and oxygen molecule. The molar ratio of potassium fluoride, water, and oxygen molecule respectively is. So for this, you need to write the balanced chemical equation. So the equation would look like this. Fluorine react with potassium hydroxide. You get potassium fluoride, oxygen, water, molecule. So balance this equation. Put here 2, 4. Then you have 4 water molecule 2. Balance the equation. So for 1 mole of fluorine, the molar ratio would be, you have here 2 moles, right? So for 1 mole, we are writing, let me first write down all the required chemical names. H2O. Okay. So for 1 mole, the molar ratio, the 1 mole of fluorine, the molar ratio would be, for 1 mole I'm writing, okay? For 2 mole, you have how much? For 2 mole, you have 4. For 1 mole, you will be having 2. And in the same way, you can proceed on. This must be 2. Oxygen will be half. And water will be 1. So B would be, question is asking KF, water, and oxygen. Only this one. Okay. KF, water, and oxygen. KF followed by water and Oxygen. So 210.5 B would be the answer to question number 43. I hope it is understood. Let us solve the last question. 44. A greenish yellowish gas reacts with alkali metal hydroxide to form halide, and it can be used in firework safety matches. The gas halide respectively are. So chlorine is a greenish yellowish gas that you should know, okay? The physical state of matter also becomes important here to solve this question. When this reacts with a metal hydroxide, probably potassium hydroxide, it gives potassium chloride, potassium chloride with water molecule. You can do the balancing, the stoichiometric coefficients here. If I write it 3, I'm going to put here 5, 6. Now here 6 to match with this potassium. Done. Right now you are left with 3 molecules of water. Done. Balance is completed. So potassium chloride is used in firework and safety matches. And this greenish yellowish gas would be the chlorine gas. So 44, chlorine and B. Chlorine and potassium chloride. This is also known as halide or chloride. Okay, as usual, you solve this last question. Yellow is ammonium sulfide is. And you can give the answer in the comment section. Thank you for joining up to the end. We shall meet in the next episode. Happy learning and all the best.